So I'm here with Patrick from Core Analysis. Patrick, you're doing a report at the moment on the RAN Intelligent Controller. That's one of the things that's being discussed here at the summit. There's a lot of hope and excitement around the RIC about what it could bring to the market. Is that excitement justified?
I think it is justified in the sense that at the end of the day, what the industry wants is to be able to manage the radio access network in a more optimized fashion. At the end of the day, until 5G, operators were really creating one connectivity product that was the same for everybody. Whether you're a person, whether it's a smartphone, whether you're an enterprise, whether you're a CEO, the connectivity product is the same for everyone. The promise of 5G and future is that you are going to be able to create new technology, new connectivity products for different devices, for different use cases, for different geographies. In order to do that, you need to be able to program the network. And one of the ways to do that, specifically in the radio access network, is to basically being able to create slices or different type of experiences. And it's possible to do that today outside of RAN, and it's called slicing. But the mechanism to enable it are not all there yet. The difficulty is to do that, particularly in a multi-vendor environment, and that's where Open RAN comes in. You had in the past self-organizing networks that were the premises, if you want, of this, being able to program the radio access network and provide specific capabilities across multiple vendors. It didn't work too well. It didn't work too well because it wasn't the standard. It were a number of companies that were doing proprietary integration with a number of vendors in order to provide that abstraction layer. What Open RAN is doing with RIC is basically standardizing that abstraction layer and providing this as a platform, in the sense that the RICs, because there are two RICs, are designed to be platform where developers can create apps that can be then loaded onto those platforms in order to do a variety of different things. So here at the show, we're talking about the first apps that are emerging, mostly around power management, because obviously it's a big part of the concerns in telecoms right now, how to be greener, how to grow in terms of capacity without having to explode in terms of energy consumption. So that's one RIC aspect that we see, one app. Other apps are more around like traffic steering and traffic management. So all of those elements, if you want, provide context for how networks are going to evolve over time to create those connectivity products that I was mentioning.
Okay. And do you think that's well understood in the market, the role of the RIC and the X apps and R apps? Do you think the sector gets it, or is there still a lot of education to be done?
I think we're at the beginning of the hype phase. We're at the end of the hype phase for Open RAN, generally speaking. But as far as RIC is concerned and apps are concerned, we're at the beginning of the hype phase. There's a lot of misconception. First, there are two elements, two RICs, the non-real-time RIC and the near real-time RICs, and they bear the same name, but they're very different. They're very different animals. The non-real-time RIC is instantiated in the service management and orchestration layer. So it's really the product of OSS and SON. That's the evolution of those. And basically, the way we differentiate it from a technology standpoint is basically anything that requires more than 1 second treatment or feedback, that could be in the non-real-time RIC. The near real-time RIC, in contrast, is in the RAN itself. Today, well, there aren't commercial near real-time rigs that are deployed, but today, basically, it's a feature set that is embedded within the base stations, or within the CU, DU, and RU in Open RAN. So these features, they're part of the vendor's capabilities. What Open RAN Alliance proposes is to extract those features from those products and to create basically that platform that I was mentioning. It's all nice from a conceptual standpoint. I'm not convinced that it's realistic. Non-real-time rig, it's easy in the sense that the market is used to having independent vendors providing OSS and SON capabilities, and that's an easy entry point for any new entrant, either new entrant to telecom or vendors that are in the telecom space but want to enter into the RAN space. That's a low-hanging fruit and doesn't require a lot of RAN knowledge. In contrast, near real-time RIC, we're talking a lot about artificial intelligence and machine learning, and I see a lot of people that are experts in that field, but they're not experts necessarily in RAN. But that's what it's going to take. You're going to have experts in RAN that are also experts in machine learning in order to make this work. It's not by accident that those functionalities today are embedded within the radio station, because being able to take decisions on let's say 100 millisecond time frame requires, well, a lot of knowledge of basically the mathematics of propagating radio signals. And that's not something that you just learn by looking at equations. It requires a long time frame.
So there was a suggestion here at the summit that at the moment RIC platforms have been developed for network operators, but actually they should be developed with the application developers in mind. Is that the right way to think about it?
So for the non-real-time RIC, certainly, because we're talking more about applications that are related to visualization, or applications that are going to look at a feed of logs and create basically inferences to provide insights in terms of what to do with the network with long time scales. So that is typically problems that can be solved by people that have developers that have capabilities in the theoretical space, in the statistical space. There's no problem. Near real-time RIC, I don't think that's something that can be developed really by independent developers that don't have like true deep RAN capabilities.
Interesting.
That's one aspect of it. Another thing that makes me a little bit skeptical about the setup is Open RAN was created to disrupt the RAN traditional business. And non-real-time RIC is doing just that. Basically, it's taking the old OSS, it's taking all the element management system, it's taking the old SON, and creating a framework by which you can apply that across a multi-vendor in a vendor-agnostic fashion. So that works, because there's something there to be disrupted. Like, near real-time RIC is actually disrupting Open RAN emerging vendors.
Yeah.
Because the Open RAN emerging vendors that are commercializing radio units, CU and DUs, they're not mature yet. That market is not mature. I'm skeptical that you can disrupt that market by creating the near real-time RIC and extracting value from those elements with a new set of vendors.
Interesting.
Because at that point, I don't know that the pyramid is solid enough that you can start taking cards from the bottom without all of it collapsing.
Okay. So another indication maybe that the Open RAN sector, to get to scale and maturity, still has a few years and a lot of hurdles to get over yet.
I think there's a skeleton of Open RAN capabilities that have the level of maturity that is sufficient for commercial deployment today. And we see it. I mean, in Japan, you have NTT Docomo and you have Rakuten Mobile that have deployed Open RAN at scale in a commercial network. And, the Japanese networks, they're very challenging radio environments, and they have a high level of performance. It's not, companies like Docomo would not deploy it if it didn't work, So you can make it work. And it's a decision, right? At the end of the day, it's a matter of the operator having the strategic intent to make it happen. And yes, it costs money and it costs time to make it happen, but you can make Open RAN work today. Now, if we're looking at the evolution of Open RAN and we're looking at new artifacts such as the RICs, such as the XApp and our apps, we're not there yet. It's just starting. Nobody has deployed it commercially.
Yeah.
Everybody has deployed in labs. And what's particularly interesting is that the people that have deployed things in labs are new vendors in that space, right? They don't necessarily have, they're not necessarily have the capacity to deploy or to develop or to integrate RU and CU and DU as well. So I don't know whether the result of those tests really are proving anything yet.
Okay, interesting. All right, great insights. I know that the RIC is going to be discussed here at the summit probably quite widely and of course through the rest of the year. So look forward to catching up with you as well in the second part of 2023, see how things are developing. Patrick,
Thanks a lot, Ray.
Thanks very much.
Thank you. Take care.